A0 and 0. It's not A0, it's and 0.
What's wrong with him? Did he do something stupid?
No. No, he can't do it.
Spam. Alright, ready? Got this? Aye.
So, what do you guys get for the last one?
4.37.
6.4. Why?
Wait.
What is 6.4 and 1? No. 4.12. 4.1.
I bid 7.2.
Say 1.65.
Oh, okay, that's me out. Ready to continue? I'll do it in the tutorial.
Oh, let's see.
Oh, in the tutorial next class. No, because I want to do all of them together.
0.17.
Not just log 2 divided by 4.
And we see that less than 0.15, I got 0.14, you got 0.17.
Oh dear.
C is 0.17.
True. What do you got for London?
0.17? Depends on 20 pounds. What is London?
Monica, what is your real London?
Bingo.
27.
Bingo.
27. Give me a second.
No, what?
Why
17, okay.
17?
17?
You have this song in China?
Yes. Really? Yes. What did you get? 4.4. You should be 4.3.
Whatever.
Continue. Jerry! Chrissy, we'll continue now. Did you write this down?
No, we need to answer for the last question.
I'll do it in the next class.
Tomorrow. Oh, no, not tomorrow.
Today? Yeah.
Tomorrow is next.
Yeah, we can't do physics and maths, that's ridiculous.
1 second.
Ridiculous.
Application.
Did you write this down, Jerry?
What? This is you. You said this class is tutorial.
He said next class, like 3 times.
What? We have next class.
No, this isn't the next class. This is this class.
Where's our next class?
Next class will be Wednesday, isn't
What
it?
happened to our rest time?
No, because we'll finish it in half an hour.
Okay.
Why?
But we still have chemistry.
Why? We have to
But we
wait
have chemistry, we have to wait anyway.
Q3.
3 quarter, a quarter of 3.
Clean
What
up.
about 3?
Oh, okay. Come continue.
Let's go.
Go.
Go. So,
After 10. Oh, 2000.
application. So this lesson, there isn't any maths in this. It's just a look at how we can use radioactive materials. In the exam, they ask this. So we'll look at some common uses, and I'll tell you which ones are the ones that are important for the exam. So really, I think there's 2 important for the exam. But before that, first of all, radiation is not all bad. Now it is bad for your health. That is so true.
It is good for war.
Yeah, well, yes, I suppose if your job is to kill people, it will be good for war. But it does have some applications. You can actually use it for some useful ways. The ones that are in bold are the ones important for the exam.
Oh, so wait, I have to write that down.
No. This first one here, I can try and draw it actually, because this one is, this is so small. This is the use of a smoke detector, but let me just draw it actually. It'd be a little bit easier. Okay, so let's see. You have something like this. Oh, and you should draw this. There's 2 which are important for the exam, and this is one of them, the smoke detector. Yeah.
Like the one in the kitchen.
Yeah. Has a positive one on the top. So this would be positive, this would be negative. And you have an electric field here, of course, from positive to negative.
This is C. No.
Huh?
Oh, yeah.
I can't see my own picture. Anyways, what you have here is you have a radioactive material, and what comes out of this radioactive material is, draw it in black, is alpha. Now, what charge does alpha have? Positive. So it will hit this plate.
Yes.
So this will cause. You also have this power supply here. So you have a current. Okay. Now this current is very small, but because of the alpha that hits the plate, you can see that increase. Yeah. So you get some current here. So this alpha hits the plate here. Now, what happens when there's smoke? Well, remember I said alpha is very easy to block. In fact, what can block alpha? Your skin, piece of paper. In fact, alpha can be blocked by just 30 centimeters of air. So just clean air can block it. But also, you can block it with some smoke. This smoke fills up this chamber, and this interferes with the alpha hitting the plate. In fact, I believe usually smoke actually, like if something is burning, like in the kitchen or something, the smoke usually has a negative charge. Anyway, so that's not so important. The smoke interrupts the flow of the alpha particles hitting the charged plate. So because this smoke is here, it'd be harder for the alpha particles to hit the negative plate. So what you see is the current then decreases, and when the current decreases, the alarm then is activated. And this is how a smoke alarm works. The material that's inside the smoke alarm is this, americurium. Yeah, I know it sounds like a made up name. ICIUM. Americurium 241. And its half-life, its half-life is 400 years. Yeah. Yeah, but I just put that in to have something on the slide rather than the picture. In the exam, you can make it a bit shorter. You can say so if you want you can write this, the smoke interrupts the flow of positive alpha. Less positive alpha hit the negative plate. What's the word for negative plate? It is cathode.
Yeah. Nope.
The explanation. So the smoke interrupts the flow of alpha positive particles. Less alpha positive hits the cathode. That's how the smoke detector works. The smoke blocks, interrupts the alpha charged particles.
You can go with not gate.
Yeah, you can. You set the circuit so that if the current is absent, the alarm is activated. A bit like just like a burglar alarm. If the signal is broken because someone tries to open a door, then the alarm activates. It's an activated alarm when there's an absence of a signal. Did you draw and write that? Because this is important for the exam. Let's see if this, who the heck is this? Jones. What does she want?
So our hand can do the same thing to block the alpha.
Yep.
If we put our hand inside the alarm activator.
Well, you can't actually get inside of this because this will be inside of a little cylinder with little holes in it. So like the smoke just gets into this little window. Yeah. So that means in the smoke alarm there is a radioactive material inside of it. Right there. Right above you. Look at all those alpha particles fall on you. Don't worry, the alpha particles don't leave the smoke detector. If the alpha particles can be blocked by 30 centimeters of air, the piece of plastic underneath it will definitely block everything. It's only a problem if you break it open and eat it. Don't eat smoke detectors. They're radioactive.
How can we
Don't ask me how to break it open and eat it either.
block from interrupting?
What do you mean?
How can we block the smoke from interrupting the smoke?
Why would you want to block the smoke?
Because we will be fine if our smoke.
Oh, well, I've got bad news for you. The smoke detectors in the apartments detect both smoke and temperature.
Okay. So even temperature can drop.
Well, not this one. No. I'm just saying the ones in the apartments use temperature as well. You can't really.
We can. I mean, they use the tap around that, and they got kicked out.
Yeah, that would if the security ever saw in an apartment tape around a smoke alarm, that is a big problem. Yeah, so don't do that. You could just not burn your food.
Oh, that was hard.
Yeah, that is hard, isn't it? Right, continuing. So the next one. Oh, and now you need the name as well. Americurium-241. Did you write that down? Americum.
Why?
Yeah, sorry, I'm saying as if it's Einstein.
Americulum.
Americum. No.
What is that 241?
241 nucleons.
Do we need to know the half? Yeah, I know, Monica just asked, but I didn't hear your answer.
But listen, I said no.
Okay.
Okay, continuing. So, the next one is fluorine 18.
Trace.
Now, yeah, not the video game. Okay, this is not the same thing as that. Right. Yes, not this. This particular radioactive material has a half-life of only 2 hours, which is good because you put this in water. Why would you put this in water? When you want to find a leak. For example, they will put the radioactive material in the water, and then if there's a leak underground, the coming out of the pipe is broken. Yeah, it will enter the ground. So if you have a Geiger-Müller counter, a GM counter, as you walk along you'll hear it click, 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 and you know, the ground here has become radioactive. Yeah. So this must be where the leak is. And you want a short half-life because when you find the leak and fix it, you don't want people drinking radioactive water. So a half-life of 2 hours means in 24 hours it'll be safe to drink. Because the amount has disappeared to nothing. Okay, so you can write this one down. It's not as important for the exam, but it's good to know it.
Is this the same thing we use to detect electricity? Like for example, last time Andrew's area, they run out of electricity and they have to dig down to the ground to fix the pipe or something, to fix the wire.
Depends what the cause of the problem is. If there was a leak, then you would have to use this. But I suppose, I wouldn't know how you would detect a broken electrical cable, actually. I don't know.
Could you write the explanation in sentence?
For this?
Yeah.
No, I don't. You don't need to have an explanation of this one in the exam.
Yeah, I know, but
For your own benefit.
yeah.
You could say something like the GM means Geiger-Müller, the GM counter detects the radioactive ground where the water leaks out.
What is that particle? That
One sec, yeah.
Can they ask about half-life? Because it's more device, so you could ask about half-life. What is?
Why is it important?
Yeah. And then
It could.
how can why can we use radioactive in water with fluorine in tea?
Basically, the rule is this: if you need it to work for a long time, like the smoke detector, you should have a large half-life, so it will keep running. But if it's going to be put into something that people will consume, like water or food, you want a short half-life. It's as simple as that, because you want this to be radioactive for a small time. Whereas with the smoke detector, the worst thing that could happen with a smoke detector is it's no longer radioactive, and so if it's no longer radioactive, the alarm will continuously go off because there's no more alpha particles, so of course you don't want that. Yeah?
If they put it in the water and how the radio they need to put in water.
Oh, how would they even know this? Because what would happen is there'd be a drop in water pressure for some homes. So it means there was a leak somewhere between A and B. But the problem is, like in Ireland, the water network is so old, there's no way of knowing where that leak is. So like the water plant could be 5 kilometres away and you would have a town that has low water pressure. So if you can't see where it leaks, then you have to search. Usually, when there's a leak, you can see some evidence of it, like it'll be bubbling out of the ground or something. But if it was underground deep enough, then, how would you know? You wouldn't know. Okay, continue. Now, the next one is Technetium-99M. And this is the stuff they put into you in the hospital.
Hulk.
It's not the Hulk. Or is it the Hulk? No, it's not the Hulk. So this fella here, I'd say he's 50 years old, bald, could lose a little bit of weight, and he is in the hospital. And the, huh?
Sure.
What?
She doesn't have a neck.
Yeah. He's a big fella, I'd say. Continuing.
Maybe that's not a human.
I don't know. Continuing. It's not the Hulk. It's not the Hulk. Oh. Continuing. So, when you go to the hospital, they sometimes need to check if there's something sick inside of you, something wrong inside of you. Now, X-rays are great, but one big disadvantage of X-ray... Jerry, I'm speaking. One disadvantage of X-ray is that... Now, if you speak while I'm speaking, I will slap you. One disadvantage of X-ray is that it only detects broken bones.
Yeah.
Broken bones. But maybe you might have something torn inside you. Maybe you might have a tumour. In other words, you might have something wrong with you that's not your bones, that's inside of you. Now, what they do is they give you a drink. Yes?
Yeah.
They give you a drink of this material. And this actually makes your whole body radioactive. So you can actually see the tissue, like the fat and the muscle, the tissue. So, no, tissue is another name.
For a lot of cells.
Yes. Now, this is actually good to see because you notice that there are two parts which are darker than the rest, here and here, here and here. Yes? Yeah, there's actually a good reason for that. Does anybody know why these are darker than, say like his arms? Like, what are these things here and here? Yeah, but what is here and here?
Limb.
Yeah.
Limb.
These are organs that try to take bad stuff from your body. So you see how they're working at trying to remove this from the body. So they collect here, and the body's trying to get clean, trying to get rid of it. Here, this is his liver. His liver is a different colour because the liver has a similar job. The liver also tries to remove toxins. It tries to clean things up as well.
Our liver is there.
That's our liver there.
I thought it's low.
No.
That is like our breath.
No, that'd be higher. Well, see, this is his intestine here, I think. Yeah.
And that is 4.
What? No.
It's kidney.
No. Well, I don't know, because it's possible that this guy here, one of his kidneys is damaged, because you see this one here is red and this one here is not. What? Are you being dirty over there? Please, this is a scientific classroom, please. I don't know. Anyways, why do you think the half-life is 2 hours? Again, for the same reason, you want this to be radioactive for a small time. Now, is this harmful to drink? Yes, it is harmful, but it's a balance. The doctor and the patient are willing to expose themselves to radiation because it's more important to know where the problem is than not to know. I think that gel is more to do with hygiene and actually just contact rather than anything useful like this. Yeah, but that's using an ultrasound, I think. I think what's good about this is you can see like everything, but it's really good for showing up growths, you know, because if there was some, let's say he had some cancer cell on his kidney, then this would damage the kidney's function to clean. What? Oh my goodness. Okay, anyways, continuing. We'll leave this poor man alone now. Yeah?
After 2 hours, it's really gone.
No, it's only half gone.
Like, I mean, if the person pregnant...
Oh yeah, no, it can't. Yeah, no, whenever they're doing anything with radiation or x-rays, it can't. The patient can't be pregnant. Now, since this looks like a 50-year-old man, he's probably not pregnant.
I think the green thing can't be
this, I would say, is from too many glasses of beer, I would suspect. This fella here looks like he has a good beer belly. I'd say that's what's going on here. He is not pregnant. Sadly, we can detect broken hearts, but no science exists to fix broken hearts.
Andrew. I'm so sorry.
Let's continue. Leave Andrew alone, would you?
But you already asked that question.
Look, Andrew and I are friends, okay? Just leave Andrew alone. Right? Now, the next one here is cobalt 60, and we use cobalt 60 like an X-ray. We send the radiation through a type of, it's kind of like an X-ray, except it's not quite as powerful as an X-ray, because for an X-ray, bone would stop it and nothing else. For the radiation that comes from cobalt 60, you can see that it kind of is stopped by the truck, but can also kind of pass through the truck. So it's kind of like a mild X-ray. It's like what they would use at the airport in the X-ray machine. You see, you don't want an X-ray machine so powerful that you can only see really hard materials. You sometimes want to see like maybe something like a wood or plastic or metal. So you use cobalt 60. It has a half-life of 5 years, and it's often used for security. Like here, this would be some kind of a border checkpoint, checking the contents of a truck, and you can see, this truck has a machine gun inside of it. Better not let them in the country.
How can you detect it?
There would be a detector on the other side, so the radiation is passed through the truck, and there's a detector which picks up what strength, how strong the signal is, and it takes this and puts it onto a computer image. It's not like an X-ray at the hospital where it's printed onto an image. I would imagine this, like at the airport, there's digital detectors that reproduce the image by measuring the signal strength. So here, because this is quite dark, it means less radiation got to this detector at that point. And here, of course, it's quite bright because this would be where the glass is for the car.
Sure.
Yeah.
Is there any radiation to put on our eyes and then we can see through?
No.
Google glasses.
No.
Like,
No. Now that sounds a bit pervy as well. You know. You know. It's like, teacher, any glasses I could see people's underwear in?
But
Why would you need X-ray glasses?
You know why?
Yeah.
I know why, friend. He wants to see the natural looking
not even I can see the girl.
No. Yeah, it's okay.
It's only the bone.
Yeah,
the
yeah,
bone
it's okay. Oh, that's okay.
I can't do anything. With the bone.
You know he's still lives, get already his back.
Oh, awkward.
Yeah.
Continue. Right, did you write this down? Cobalt 60. Got that? Yeah. Okay. Next one. Now this one here, I think this is probably the most interesting of all these ones personally, because it really shows how physics can be useful in medicine. So here we have something called boron 10. Now boron 10 is not radioactive. It's not radioactive. It is stable. So it's not harmful. So it's not harmful. So what they do is this. If I can try and draw it. So we picture here's the patient's skin, and we'll say underneath here, inside of them, maybe they have some sort of cancer cells. Okay. Then what they do is they inject and put inside of this with a needle your boron 10. Now boron 10 is not radioactive, so it's not harmful. Then what is very interesting is they would take something here which fires neutrons, and the neutrons, let's say here's the boron, the neutrons fire and hit the boron, and when your boron 10 hits a neutron, it makes something which is radioactive. So what you've done is you've made something radioactive inside the cancer. So it's like you explode the cancer from the inside. This will release alpha, beta and gamma and will destroy the cancer cell. So I think this is quite amazing really if you think about it. You inject and you fire neutrons and the radiation destroys it from the inside. And also the half-life is so small, I practically call it zero. It's like nanoseconds. It's nearly zero. So it means very quickly it's not harmful anymore. So this is really interesting research. This is what you might call biomedical physics, which is that somebody's choice?
no.
No one's doing biomedical physics? No, maybe in the January class.
Only for science.
It's very interesting for science students. It's using radiation as a cancer therapy, which is very, very promising.
How can they destroy it by the
What?
decay? Alpha particle.
Well, the alpha particle destroys the cancer cells. Radiation destroys cells. To be more precise, it destroys the DNA in the cell, which prevents the cells from reproducing. You see, all cells eventually die, but they reproduce themselves before they do. If you destroy a cell's ability to reproduce, then that's kind of the end of the line. Because it means when the cell dies, there's no replaced cells inside of it.
Anyone won't die in cancer. There's no risk.
Well, it's safer than the other cancer treatment. The other cancer treatments, they make the rest of you sick. You know, when trying to kill the cancer cell, it kills a lot of other cells as well. This is why you see people without hair, because what's happening is some good cells are destroyed in the process of killing the bad cells. But what I like about this is you can target precise parts of the body. Okay, continue. This one's boron 10. You can write this one down. It's interesting looking up. Okay, next. Cobalt 60 again. But you can use cobalt 60 for something else. Food irradiation. Does anyone know what this is? Yes, but how exactly? Yeah, but how? Like, how does it maintain or preserve it?
Microorganism.
That's it. You know that if you eat an apple, that if you eat an apple, that the outside of the apple has lots of bacteria on it. Every food item has bacteria on it. Why does food have bacteria on it? For the same reason you like food. You want to eat food. So does the bacteria, okay? So, you know, a little bit is fine, but some bacteria can be very dangerous for humans, like E. coli or other things like this. They're very dangerous bacteria. And so you don't want your food, your vegetables, to have this bacteria on it. And if they're outside all the time, then of course they're going to get bacteria on it. So how can you get rid of the bacteria? Well, you can spray it, or you can actually fire some small radiation on it. Some small amount of radiation. You kind of can clean the outside of it. So it's kind of like sterilizing. You're cleaning the outside of the food. Now you might say, oh, but I don't want my food to have radiation on it. Well, everything in life is a balance, you know. So your choice is you can either have a little bit of radiation or bacteria. Now I personally would have a little bit of the radiation, because some of that bacteria is really, really bad. Like getting something like E. coli, you know, if you're somebody who's old or very young, getting a bad bacteria infection could kill you. You know, so I think a lot of people talk about organic and natural like it's a good thing, but remember, you know, bacteria is organic and natural as well, and it will kill you, you know. So I think, personally, I don't think this is a big deal. A small amount is going to be okay for you, and it's going to be better than a lot of bad bacteria on it. So cobalt 60, if you can write that down for food.
Still,
Yeah.
what about Japan? Is there only pure food?
For what?
Nuclear. There was an expert.
Oh yeah, we'll actually have a lesson talking about that as well. Nuclear disasters and reactors, how they can malfunction. Now, there is one other use of this. The bacteria is bad, but also what else is bad is insects. You don't want to eat an apple and have a worm inside of it. No. You don't want little eggs of spiders on your apple, do you? No, you don't. The cobalt 60 is very good because it makes any insects that were living on the food infertile.
Oh, that's so cruel. That's
So,
so cruel.
the little boy ant and the little girl ant, they can't have any baby ants because of the cobalt 60, their equipment no longer functions properly.
Oh, that's so cruel.
I mean,
Yeah.
also all Irish fruits use that because I see the apple is very clean.
Oh, we will get
No,
to the line
there's chemicals that do the same thing. So you can use a chemical that will render the insects infertile and clean the outside of it as well. I don't know which countries where this is popular. I think in Ireland it's mostly chemical based process.
And you will wash it when you eat apples.
Well, the washing is not going to remove all the bacteria or all the insect eggs. But Monica, you don't have to worry because this food is already treated and has that stuff removed.
How do you know?
Because your apple can last a really long time in the kitchen. Like if this apple was out in nature and an apple fell off a tree, it would only last, I don't know, how many days until it starts to turn bad and start to rot? Maybe 3 days, I don't know. But your apple in your kitchen, could still look quite good after a week or two. This meaning because there wasn't much bacteria on it. The reason food goes bad is because the bacteria eats it. So there's not much bacteria to begin with if it decays so slowly. And if you leave an apple in the kitchen, you won't see insects coming out of it after a week. So that means there's no eggs inside of it.
So I don't want to eat apples.
Yeah, okay.
You come from China, what's the better?
Teacher, what about
What is it?
sterilized water, like the lamb's liquid?
Most water sterilizations would be a filter or chemical.
Yeah, will that damage our eye?
I don't think so. Anyway, last one. So this is the last one which is important for the exam, and this is something we already talked about. This is the carbon-14 datum. Radiocarbon datum is a method that uses carbon-14 to determine how old it is. And was it Chrissy or Monica, one of you were asking me, maybe, or I was talking to you about the limit of how far back you can date. So you can see here carbon-14 is reliable up to 60,000 years. Okay, I would actually like you to write all of this paragraph down.
What is the group of something?
Oh, what you want to know is in the picture. You don't really need to know this for the... If you want to know, all this is nitrogen and this is neutrons, and the neutrons combine with the nitrogen to form carbon-14. That's how we get carbon-14. Neutrons and nitrogen in the upper atmosphere. The reason it's the upper atmosphere, KJ, is that the neutrons have to be travelling very fast to connect and link with the nitrogen, which you can only really get this in the upper atmosphere, not at ground level. When the neutron collides with the nitrogen, it becomes carbon-14. Nitrogen is 7 protons? Yeah. So what happens is the neutron fuses with the nitrogen, and do I have that right? It's 7, isn't it? And then I think, I can't remember. I'll have to look it up. And then there's an alpha and a beta decay, and then you're left with carbon-14. Anyways, there's a radioactive process that changes it into carbon-14. In fact, maybe even in the last lesson, one of the formulas I gave to balance could have been a carbon one. I'm not sure. Okay, you have this one? Carbon-14?
This one is the important one.
Yeah, in the exam, the two you need for the exam are the smoke detector and the carbon-14. Now, they've asked the carbon-14 many times, and they've never asked the smoke detector one. And I really, really feel like they're due to ask the smoke detector one, because they've asked this one so many times. They've not asked for the smoke detector yet. So that's my little prediction is for this year is that they'll have to eventually ask the smoke detector one. Huh? Let me get you the precise learning outcome here. Do you have this? What take us along? Yeah. Yeah? Now there isn't any homework for this because they're all just pictures. The learning outcome is describe the use of radioactive isotopes in smoke alarms. So what I said, like the diagram and my sentence is enough for this. And then the second thing you need for the exam is describe carbon datum. Yes? It's a datum method, a very effective datum method, if I may say. Yeah. Of all the different dating techniques, carbon dating the most successful. Huh? Yeah. And age is no limit. You could be as old as you like, and you can still be very successful with carbon dating. All right. Did you write that down? Yeah.
Wikipedia.
Yeah. I'm lazy.
But teacher said Wikipedia is not good.
Correct.
And
Just the only way I can know about
What's your point?
the nanotechnology.
it is used in our
There's two key differences. I'm not using Wikipedia as a source in something I'm writing for production. What I mean is, these slides are only for my use in the class. I'm not releasing this. I'm not trying to get it into a journal. I'm not trying to get this graded. Also, because I'm a physics teacher, I can more discern on Wikipedia what is good and what is bad.
Okay.
Mostly I'm just too lazy to type this myself, so I just copied and pasted it. And I didn't feel like it'd be appropriate for me not to say that I got it from Wikipedia. But it's different standards for different jobs, you know. Since this is only for a presentation in the classroom, there's no problem using Wikipedia. Although, if I was being graded, then it would be a problem. What's wrong?